So we're going to start off where we left off yesterday, and I'm going to continue to follow the Additive Manufacturing Technologies textbook, okay? But today we're talking about processes, terms, and benefits. So we are going from section 1.3 through section 1.5 within this presentation. So we're going to start off with what processes are used throughout within the additive manufacturing process, okay? How do we go from an idea to a tangible object? So the first step in the process is the CAD model, okay? And so the CAD model is where every single one starts, okay? And that the additive manufacturing uses three different types of CAD models. So the first one is we have the 3D modeled object, which is anytime we work within Revit, SolidWorks, and I believe even within Revit, we're working within that 3D model, okay? So that's the form that we are the most familiar with, okay? Next, you have the 3D surface, okay? So it looks more of how you're able to go about via the surface forms. We don't do a whole lot of that in here in this class, but as you get more and more advanced, there is a higher chance that you will be doing some surface modeling and looking at how to do stuff with there. The last part is, the last file is the reverse engineering. So it's kind of the idea of the data set in which you're able to get from reverse engineering or 3D scanning a product, okay? Because all of them run off of descriptive geometry, okay? And so you need that data of the geometry to 3D print apart. And that each one of those, whether it be the 3D model, the 3D surface, or the reverse engineered part, all give descriptive geometry that will inform the machine what it needs to do, okay? Once you are done with that, typically you convert the 3D CAD model to an STL. The STL file is it's a general CAD file. It's actually it's a general print file that all CAD software recognize. So some of the things that so it's kind of the idea of, if you notice, SolidWorks has their parts and Inventor has their parts, and they don't play real well together. They can, but they don't, and there's reasons for that, because the competitors don't want excuse me, SolidWorks doesn't want Inventor or Autodesk getting stuff from them, vice versa. And so along the way, there was another file type that was created called the STL file, okay, or the stereolithography file type, okay. And stereolithography is one of the original forms of 3D printing, or additive manufacturing, excuse me, that I'll get to later on. But it is one of the general file types. Now I will say a lot of the softwares are starting to use more basic CAD models and converting them themselves, and so you don't need the CAD file, the CAD system, to really convert it to the STL. But it is what's going on. So nearly all forms of additive manufacturing machines accept the STL file, okay? It is the de facto, okay, standard file format. All of them use it. From one way or another, for one reason or another, everybody uses it. What it does is it describes the external closed surfaces, and so it gives the object the descriptive geometry that it needs to be able to make it, okay? And the file was originally made for the additive processes, or the 3D printing. So our first step is to model it in CAD. The next is convert to an STL. Okay, from there we have to file transfer and manipulate. Okay, in a lot of cases, with our different files, we're able to still do that on a computer. Okay, if we're printing to our Stratus, we're doing this in GrabCAD Print. Our new ones we uses a different one. I wasn't sure. So when we're talking about file transfer and manipulation, we're talking about the size or the scale. Are we scaling it up? Are we scaling it down? Will it fit within our build envelope? Okay. Or build platform. So it's kind of what there. Some of the other things you may play with is the number of, okay? How many times can we build this? Next, you have the location of the part on the platform. So no matter what you build it on, so if we think about our Stratus, we have this rectangle, I think it's like 8 by 12 by 18, and we have to print within that box. If we cannot print within that box, if we can't get it to fit within that box, we can't get it to print. So within that file transfer, as we're working on GrabCAD Print, before we've sent it to the machine, we have to locate the part and make sure it's within the build envelope. We have to check the orientation, like yesterday when I was talking about the face shield. I was playing with the orientation to limit the amount of support material. Excuse me. And so that's one of the things that you have to do that, and by doing that you can speed up time, reduce material, so on and so forth along the way. One other thing you may change is your layer thickness. Like I said yesterday, the thickness matters. Okay, the thicker the material, the slower it takes before it moves to the next part. Other things are the more precise it is, and the smaller the material, but the longer it takes to print. Some machines you have to do it on the interface on the machine. I will say with our Stratus, we do that with a GrabCAD. I'm not sure about the Artemis system yet. I haven't really ran it enough to know what's going on. Okay, so once we have the file manipulated, okay, and the correct orientation on our print software, we then have to go to machine setup, okay? And within there, we are worried about a few different things, okay? Our material constraints, okay? For example, do we have enough material loaded on our spool, that allows us to print the part we need? Or do we need to change color? Or change spools, not necessarily change colors. And so that's one of it, is to make sure we have the right material. Next, with this one here, with the two that we have, we need to see that we have the proper amount of energy needed to be able to do it. So like I kind of hinted at yesterday, every different type of 3D printer or additive manufacturing machine uses some sort of energy. The Stratus and the Artemis both use heat and melt the parts together. So making sure that our machine is up to the right temperature, because with our Stratus, it has an oven. So basically it bakes the material, where on the Artemis, it has a heated plate that is used, okay? Unless you have, maybe you have machine calibration, where we go through and we are figuring out, is our machine adequately running at the proper way to be able to print the part? Are our tips in the right location? Is our build plate at the right location? So those are just some of the different things that you have to do to be able to print the part. Okay. Next in the additive manufacturing process is the build process. Okay, and that is one of the one of the simplest processes you can do. So you have so in the build process, it's relatively automated or completely automated. You can't touch it, you can't deal with it. I would highly recommend that as it's going on. And the reason I bring that up is because the Artemis you can go in and touch it. But I wouldn't do that because one of the things that occurs with you going in and touching it is you're able to burn yourself because things can get really hot. So you have so on the build process, it's automated, okay, but you do need to check it every once in a while. And I will tell you, I have been taken advantage of, or for lack of a better term, burnt because of not checking it or just letting it run at home, okay? Because you want to occasionally check it because you want no errors. If there happens to be an error, you either need to stop the machine and try to restart. Oh, excuse me. Or if there's a clump, you're able, maybe you run out of material and it's time to switch materials. So that's some of what's going on. Next, you have material supply. Well, you make sure that your part is being fed, or the extruder head is being fed enough material so it can properly print your product, okay? And the last thing you're checking throughout is power. Yeah, I want you to be aware of, compared to some objects in our building, a 3D printer doesn't use much electricity, so very little power, compared to some of the arc welders. But it is, of my pieces of equipment, I almost guarantee my 3D printer uses the most. But that's because of the oven, and so heat takes up a lot of energy throughout. Okay, so the next step after the part has been built is you got to remove it. Okay, so you're gonna go through, you're gonna remove the material somehow. Okay, or so within our Stratus, you're able to remove the plate and kind of break off the bottom plate or bottom table off the plate. Artemis, it's when it cools, it actually starts to peel off a little bit of itself. And then you have to go remove more material. When we have the Object 30 running, you had to scrape it off. Get underneath it with like a putty knife or a scraper and pry it off. But all of these, with the Stratus and the Object 30, you had to have interaction with the part. For example, in the Stratus, the oven door. You cannot open the oven door unless it allows you to. And so it has processes along the way for safety pieces. So you can't stick your arm in that hot oven on that hot extruder that's going to, really burn you pretty quickly, nor are you going to get your arm caught on a moving part because of the way that it's designed, that if anything is moving in that project or problem, it has to sense that the door is closed, and the door is locked. So that's what's going on. We will continue on with the advanced manufacturing processes in a little bit. All right, thanks guys.